All right. Looks like we are live right now. Finally, that's awesome. Welcome to another video this week. And as always, if you have any questions, just let me know in the comment section. And today's live stream is just a continuation of the project I've been working on. Nothing special. And I'm not gonna go through the project from beginning to end. You can watch the previous videos. But basically, what I'm trying to do is I'm trying to refactor my code. This was the original project here on this side. And you can see how the code is written. But this video, this one that's a premium 2 is the notebook I'm using to refactor the code. So I'm going to be refactoring my code today. And basically last week I laid out a plan, an action plan of how I'm going to refactor this code, like what needs to be done in order to refactor this notebook. So this is the plan I'm going to be following. And of course, I'm going to be changing it a little bit as we go. And I like to lay out plans like this up front because it just makes life 10 times easier to kind of have a plan of where you're going, and you're like, oh, this is where I'm going, this is what I'm looking to accomplish, instead of just writing random code and hope for the best. So with that being said, let's go ahead and start coding. I'm hitting Shift Enter on my keyboard just in case you don't know. Shift Enter runs the code cell and goes to the next code cell. Okay. All right, so let me see, what did we accomplish last week? I should probably check this off. Let me see. So if we go down here, this is, we wrote the wrangle function. We created the split data function. And then we created a function for encoding our data. So I believe this is what we are working on last week. We didn't finish this because we figured this is going to be a really long function. And this function is just encoding this data set. So let's see here. Let's see how far did we get. So creating a function for encoding the data. Encode coverage column from categorical to integer. We've done that, so we've done category column. We've done coverage column, and then we've also done the education column. All right, so let me see. So we've done this right here. We've done we've encoded education column. But can you mark things off? How do you let me see, strike through in markdown? How do you do strike through? Create a crossout text, use the tilde and markdown twice in a row, followed by respective text, then another 2 slices. So basically use this, Control C. So if we do this, it's supposed to create a markdown. Let's see. That didn't work. It's supposed to strike through. Let me see. Let's try again. We are going to figure out how to. Oh, it works. Oh, snap. I get so excited when stuff works. Okay, so this is awesome. I figured out how to do strike through and a markdown. Oh, this is awesome. Okay, so this is gonna make it just a tad bit easier to keep track of what we are doing here. So Oh, you don't even have to do it at the beginning and the end. You can just do it at the beginning. Huh. Oh, actually, I think it might need the end, because if I backspace this, then it's gonna get struck through too. But then if I do it at the end also, then this will not get struck through. That makes sense. This right here is just specifying where the end is. But this is so cool. Oh my gosh. I get so excited. Uh so let me see. Um let me backspace all of this. Alright, so we've done this also. Alright, so we've done encoding education column. So now we are working on one hot encoding to encode employment status. So let's go ahead and save this. And then I'm gonna move this down a little bit so I have it below this one. Let me see. How do you move stuff down? Is there like a key to press that you can just move stuff down? Okay. I wanted to move it down so that I can have it right here to make it easier to look at it as I'm writing the code. And this down here is kind of where we experiment with our code as we are writing it, so that we know the function is working. I don't want to like write a gigantic function and then at the end the function doesn't work. I'm gonna be really pissed off if I do that. So that's why I always test my function as I'm going. All right, so let's get back to this. So now we are going to use one hot encoding to encode employment status. One hot encoding to include employment status, and then all right. So this is the original notebook, like I said earlier, and this is the notebook I'm using to do the refactoring. I'm basically taking everything in this notebook over here and putting it in a function. It will also make it easier, and also when I build my Plotly app for this project to kind of create a user interface for this project, it's going to be so much cleaner, so having clean code is important. Alright, so we are looking at the employment status column. So let's see, how did we do that? So that's education. Okay, so this is a different function I created for rounding various distance. Let me go ahead and add a distance title here. So this is rounding various columns. All right, and I want to actually, that's a good idea. Let me go ahead and add a markdown to each one of these. This one is encoding various columns. So this is function. To make it easier, and also if you look at this notebook, like the link to this notebook is in this thing below. If you look at it later, is to make it easier, but I'll go back and finish this later and finish putting titles to the functions. Alright, so let's keep going here. So this is the employment status thing, and this is the encoder that I used to encode it. So I'll just go ahead and copy this, and since I'm just doing refactoring, I'm not like writing super new code. All I'm doing is kind of like copying the code I already wrote. I'm gonna do this on top. All right. So let's see here. So we have these are our inputs. We are creating a copy of this input data. So we are encoding the coverage column, and then we are doing that, and then we are encoding the education column. All right, so train encoded. I want to make sure I'm keeping track of myself here. Education encoder. All right. All right, so implement encoder equal to this. All right, and then train encoded is equal to implement encoder that fits transform train encoded. Okay, and train encode test encoded is equal to implement encoder that transform test encoded. All right, and I'm gonna repeat this process for the validation process. For the validation data set, so validation encoded is equal to train dot val encoded. All right, so I have train encoded, test encoded, validation encoded. So basically, I am updating this, and here instead of using education encoder, I'm using implement encoder, and I'm doing one hot encoding on the implement column using one hot encoder. All right, so this should work. Let's go ahead and run it, and then let's go ahead and run this code cell and see if our column works, if our doesn't work. So name train is not defined. All right, so I have to run the other functions first. Let's go ahead and do this. I like error messages, like they make life so much easier. You don't have to guess what's wrong with your code, like it just tells you, so splitting the data, and let's name this function. All right, and if you just hit M on your, if you click here and hit M on your keyboard, it will turn this from code into a markdown. So that's what I've been doing. So let's call this cleaning the data a little bit. Alright, so that's what this code cell is doing. So we need to run this here. So I have to make sure I run all of this first. And then run this. Okay. Now that we have our training data, let's go ahead and run this again. Alright, so it works now. I said train test validation here, and we didn't run the code cell above. So it was like, I don't know what train means. Alright, so let's just try out our training data, and let's see if it works. Alright, so it does work. So our one hot encoding worked as expected. So here, right, we wanted to transform employment status using one hot encoding, and this is the original data. Do I have that? Let me show you the original. So if I do the original here, or I can do it directly below this, I can do insurance to head. So this was the original. We have employed and unemployed as the employment status. And then when I did the one hot encoding, it created a different column for different employment status. So we have employment status employed, employment status medical leave, employment status unemployed, employment status disabled, employment status retired. So basically created a new column for every single category of employment status, just like we expected. This is one hot encoding. That's how it works. And yeah, so our function is working as expected. That's pretty good. And I know this is going to create, I know these columns look weird. In a different function that we are going to be writing, we are going to rename all of this. So we are going to have a function called renaming, where we rename all of this. So don't worry, we'll get to that eventually. But for now, let's just focus on this encoding column. All right. So we've done the encoding column. Let me use my new favorite found trick. Or not this. Yeah, this right here is my new favorite thing. Using the tilde sign, it is so cool to create a strike through in your markdown. So we've done that. So now let's move on to the gender column. So let's go back here to this is the renaming step. We are going to use this code in our renaming function. So so now we are moving on to the gender column. So let's go ahead and copy this code here, and let's go back to our function. So now that we are done with the employment status column, let's go ahead and move on to the gender column. So gender encoder, gender, use category norms equal to true. And then train encoded, test encoded. And again, I'm gonna copy this so that my validation data set will also be updated. And again, it's just, this is another one hot encoding procedure. And I'm doing one hot encoding on the gender column. Alright, so let's go ahead again and run this, and then come back here and run this and make sure our code is working as expected. So let's go all the way to gender. Yep. So our code is working as expected. So we have gender M and gender female. So this is one hot encoding. So the gender column is one hot encoded now. That's good. Now let's use again, let's use my new favorite thing. I get so excited every time I use the tilde key, because I'm like, oh, that is so cool. I can just use it to create a strike through in my code, in my markdown. So now we want to do one hot encoding for the location column. So let's find it here. Let's see. So this is location, and I think location is state. No, hold on. Actually, there's something called location code. Let's see. Let's find it real quick. Location code. I'm gonna do all this process, but at the end, I'm actually only going to work with like 10 columns. I'm going to get rid of every other column and only work with 10 columns. But still, I wanted to go through this process and have this code all clean and stuff, so that in the future, when somebody comes to look at this code, they will know the process that I went through to get the results that I have. Or to build the model, I want somebody else to be able to rebuild this model, right? So it's all about reproducible research. Back in my day when I was younger, in college when I was doing my bachelor's in biochemistry and masters in chemistry, I they always taught us about reproducible research. Like whenever you're doing research, you want to record everything. Whenever you're doing any work, you want to record everything because you want somebody else to be able to reproduce the work that you did. So that's kind of what I think about when I'm writing code. It's like I want to write my code in such a way that it is easily reproducible. All right, that's why I'm creating these functions. All right, so basically this is for the location. This is for the location column. We are encoding it, and I know like when you get into data science, you find out that data science is not as glamorous as they make it sound in the movies. Like whenever you look at the movies and data science, or should I just say AI, looks so cool. Like it looks so awesome and stuff, but in reality, it's not boring. I enjoy doing this. It's not boring at all, but is definitely less, what should I say, exciting, like less intriguing than Hollywood makes it appear. So let's make sure our code, the encoding we just did works. And let's scroll all the way to the end. Yep, so our encoding was successful. All right. And I know it might seem redundant to keep checking this to see if it works after adding a new thing to the function, but it's actually critical to make sure that everything you're adding, with every addition to your function, the function is still working. Because then if something's not working, it will make it easier to catch the error early, instead of like waiting all the way to the end and testing your function and then find that your function doesn't work. And if your function doesn't work, then you have to go back through everything and kind of find out where stuff went wrong. So all right, let's see. So we've done one location code. So we want to do marital status, policy type, policy, sales channel, vehicle class, telecom. So we have a lot of encoding to do. And it makes perfect sense. Like look at the original data. Most of the things in this original data is text. It's like all text distant columns. And we have to encode these text columns into numbers because our model doesn't understand text, it understands numbers. This is not a natural language processing project. Even if it was a natural language processing project, we still have to take the text unit test, the corpus, which is the individual text, and turn it into some kind of number, and kind of sometimes you have to do mathematical calculation to find out the meaning of a sentence, right? So at the end of the day, it all comes back to numbers. Whenever we are dealing with text, that text eventually gets translated into numbers. Sometimes it gets translated into probabilities, right? So we can be like, so what is the probability of this and this word and this word being next to each other? And that's kind of how the machine will know that this is what the sentence is trying to say. That's how machines are able to interpret text, interpret text like sentences by calculating probabilities and between two words. So it all comes back to numbers in some form, even if we are dealing with text. And our regular models, like the random forest models, the gradient boosted models, they don't understand text like this, so we have to convert it into numbers, and that's why we are doing all this encoding stuff. Encoding is just one way to turn it into numbers. Anyway, enough talking. Let's go ahead and keep encoding. At this point, I'll probably just keep quiet. There's nothing much to say as I finish copying over this encoding codes. Oh my gosh, I just discovered something. So, actually, I don't have to have. Oh my gosh, I feel so stupid right now. I legit feel dumb and stupid. Like, why did. Oh my gosh, I hate it when stuff like this happens. Like, I've wasted so much time for no reason. I feel so dumb right now. Like, I legit feel dumb. Um, oh my gosh. I just legit feel dumb right now. Instead of doing my one hot encoding, um, using individual codes like this, I could have just done it using a list of columns like this, because if it is something like ordinal encoding, I have to specify the encoding process, so it makes sense to do it individually like this. But if it's something like one hot encoding, I am not specifying the encoding criteria like this one. The encoding criteria is going to be the same for all of them, right? I'll just give it a column, and then it will do one hot encoding on it. And I've covered one hot encoding in a different video. You can go ahead and watch that video on one hot encoding. It's gonna be somewhere on my channel. If you just search my channel and one hot encoding, you'll find it. But instead of doing it individual like this, I could do one hot encoding by putting everything in a list like this. So yeah, oh my gosh, I'm going to have to delete all this code. See, that's the thing with live coding. Alright, so I'm gonna put, I think I have one more ordinal encoding to do for the vehicle column. I feel so, I can't believe I didn't think of that before. I mean, I even did it here. Like, look, I did it right here. I listed a list of columns and just did it in this line of code instead of having several lines of code for like different one hot encoding. It's like, okay, whatever. It's happened. So let me go ahead and do this vehicle. Let me go ahead and do this ordinal encoding for the vehicle column. Then I'll go proceed to do one hot encoding for the remainder of the columns, and I'm gonna use this structure right here where I use a list, instead of like writing individual lines of code for everything. Like, I can't believe I didn't think of that before. All right, so let's go ahead and work on this. So that's the mapping. right. So that's the dictionary. This is the encoder. And I'm gonna copy this. All right. Then I'm gonna do I'm gonna let's see. All right, so now I'm gonna do the one hot encoding. So I'm gonna end up deleting all of this code, right? But for now, I'll leave it there. So these are the columns I'm going to do one hot encoding for. No, actually, for vehicle class, I'm doing ordinal encoding. But no, I'm doing it for vehicle size, not vehicle class. Never mind, don't mind me. All right, so so this is why you refactor your code, so you don't have like all this encoding separate. So because the way I had it written before, as you can see, my encoding is all over the place in this notebook, but with this refactoring in place, I'll be able to have all my encoding in one function and in a concise manner. So I'm gonna add gender to this encoding. Location code. Is that it? I feel like I'm missing one. Education. No, employment status. All right, so these are the columns. I want it to be aligned. All right, so these are the columns I'm going to encode using one hot encoding. As far as I can tell, that's all the columns. I'll go ahead and delete this right here because I don't need all of this. See, this is what I'm saying. I wasted so much time writing all that code, like when there was a more efficient way to do it. All right. So let me make sure I'm on the right path. So I did ordinal encoding for coverage column, for education column, and for vehicle size. And then after that, I'm doing one hot encoding for all these columns. But I'm not going to write individual code for each column. I'm just going to write a few lines of code that's going to encode all these columns at once. That's what I said, saying that, oh my gosh, I feel like, oh, why didn't I think of that before? All right, so let me see. All right, so I'm gonna use this code to do my encoding. All right, I already got this taken care of. So these are the columns I'm going to be encoding. So columns encode equal to see either one hot encoder, and then columns is equal to this. And the columns I want to encode is in this list, and then train encoded, test encoded. I'm going to copy this and change this to val so we can also work on our validation data set at the same time. All right. So let's see here. So I'm gonna run this code. If we run into any errors, that's perfectly fine. We'll just come back, look at the error messages, and figure out what's wrong. All right. All right, so let's go ahead and run this. And now the moment of truth. All right, so something is not right. The state column was not encoded as expected. Let's look at the other columns. So employment status was encoded, location was encoded, marital status was encoded, policy type, person was encoded, renew offer type. I think I was gonna I think I left this here because I was thinking renew offer type might have an impact on customer lifetime value. When I originally worked on this project, I dropped renew offer type because I was like, it didn't add any value. But now I'm rethinking, maybe it does add value. Maybe, just maybe, the type of renewal offer a customer gets will determine their lifetime value. So I'm gonna leave this here, and I'm gonna add it to the things I want. Oh, well, it makes perfect sense. Well, state did not get encoded because state wasn't on this list. I'm just silly sometimes. Alright, so we're gonna add renew offer type to the columns we want to encode, and of course we want to add state. I think I ended up doing one hot encoding for state. Let me just verify real quick. Yeah, I did do one hot encoding for state. And again, this is why you do refactoring. When you refactor a code, you'll be able to cancel. It's like a cancellation. No. How do you say that? Let me see. Hold on. Combination synonym. Do you ever do this where you are thinking of a word but you don't know what it's called? So condensing. Yes, it's a condensing. It's a condensation process. That's what I'm trying to say. Condensation. So basically, when you refactor your code, the goal is to condense your code. And condensing your code means one, your code is not going to be like scattered as it is right here in this notebook, but it also means your code is going to be easier to read, it's easier to follow, and it's just overall more concise. So I've added state and renew offer type to the columns we want to use one hot encoding in, and I think that's it. Those are the only columns we want to add to one hot encoding. So let's go ahead and run this, save this, run it. Run this and run this. All right, so all these columns has been encoded. So we only have numbers now. So that's pretty good. That's awesome. All right, so I'll go ahead and add my tilde right here. Oh my gosh, this is my new favorite thing to do. It gets me so excited. So we are done with this objective, so we are gonna leave it, and I'll come back and clean up this code a little bit more in the future after we are done refactoring. But for now, I'm just gonna keep moving forward. So our encoding process is pretty much done. So we've created a function for encoding every single column in this data set. That's pretty good in my opinion. Let's see, what else did we have on our to-do list? And I'm gonna copy this too and move it down so I don't have to keep coming back here. So we want to create a function for changing column names after encoding. And then we want to create a function for rounding various series. And then we want to build the models for insurance premium. And then we want to build the model for customer lifetime value. And after we finish refactoring, we'll begin our Plotly app. So yeah, we just have a few more functions to create to refactor this, to finish our refactoring process. And get started with building a user interface. So if you don't know what Plotly is a way for you to build a user interface for your code. So basically, instead of writing JavaScript, HTML, and CSS code from scratch for building a website, you can use Plotly Dash, make a few changes, and be able to have a website for your project. That's kind of what I'm planning to do. So right now, and also moving forward on Saturdays, I'm going to be working on projects like this. So once I finish this insurance premium project, I'm going to go back to my previous projects, and I am going to I'm going to refactor some of them, but also I am going to create a website for my project, so that my portfolio will kind of stand out a little bit more, right? I'm going to create a website for each one of my projects where users can interact with the result of the project. So that's kind of my plan moving forward. And of course, I'm going to live stream all of it on this channel, so it's going to be fun. And so this is what we're working on now. I'm going to go ahead and delete some of these that we don't need. So all of this is just redundant at this point. Okay, so this is one of the things we're working on. I'm just gonna leave this here for now. But for the most part, I'm going to create a function for changing column names. So if we go back here, rather than this, all right, so if we go back here, right, as you can see, after doing our encoding, you can see that we have many new columns. All right, so if we do if we do train encoded dot shape, you can see that we have 56 columns. All right. Why before doing this, if you do train.head, now train.shape, as you can see, we started with 22 columns and now we are up to 56 columns. So after the encoding process, we are at 56 columns, and that's what, like 34 columns more. So and the names of these columns are not ideal. So basically I'm gonna create a function for changing the names of the columns to something shorter, something more easier to write and pronounce. Basically I'm going to be changing the names of the columns. So I'm gonna create a function for changing the names of the columns. Again, it's a good old boring process, and nothing fancy to see here, so you can zone out if you want to. So let's call it a def rename. Rename is a keyword, so I don't want to use it. Change name. And let me see, how do I want to do this? So I want to be able to pass in my so I want to be able to pass in my data set, and then it's going to perform the name change on my data set. All right, so how do I want to do this? I think I want to pass in something like train encoded, test encoded, and val encoded. So that's what I'm going to pass in as my parameters. All right, and then I want to create a copy of all of this. So I'll just say train is equal to train encoded dot copy. Test is equal to test encoded dot copy, and val is equal to val encoded dot copy. Also, it's a good idea to add comments to your functions so somebody else reading your code will know what it's for. So basically here what I'm doing is I'm renaming the columns after encoding into something shorter, right? And below here what I'm doing is creating a copy of the data set. It's good to have doc strings in your code. Function to encode some columns using Arduino encoding, and others using one hot encoding. All right. So I already mentioned this. Let me see. I'm gonna put this inside the function instead of outside the function. Well, I can put this as a doc string. You know, doc strings is how you have multi-line comments in Python. In Python, there's no like easy way to have multi-line comments. So doc strings is kind of how you accomplish that. All right. So I've gone back and added some kind of doc string to kind of make it easier for me in the future, and also make it easier for somebody else to kind of understand what the code is supposed to be doing. All right, so now we have a copy of the data set. Let me see, how do I want to do this? So if do I want to do train? Okay, so oh, also I wanted to add another something here to my doc string. The input is the encoded data frame, or any data frame that needs to be renamed. So of course this function I'm writing is going to be very specific to this code, but I can reuse this function in the future. That's why I want to create stuff I can easily reuse. So let me see, how did I do this? Let me see. All right, so I'm gonna call it columns to rename, and it's going to be in a dictionary format, and basically this is gonna be the information. All right, let's say Control Z. All right, let's see what we got here. No, please don't make me do this. Hold up. Can just collect all of this and then do Shift Tab. Shift Tab. All right. So now it's at the right and left. So these are the columns I'm going to rename, and this is how I'm going to be renaming them. All right. And I've already done some renaming earlier in the notebook. So if we go here, all right, so all right, so this is where I did some renaming. So I'm going to copy this code also and add it to this list. All right. Okay. And then don't mind me, I'm eating chestnut. Chestnut is my newfound obsession. Mm, I think that's pretty much it. I think this is all the renaming that needs to be done. I don't think I did any more any more renaming. So employment status was the first one where I did one hot encoding. Mm, I think one thing I could have done better is when I did the one hot encoding here, I think there's a way to specify what the column names should be. But then if I had done it like that, it would be more, and then how did I say confusing, to be more cumbersome. Like if I had put right here what the column names should be after this code is done, then this whole process, like this code is gonna look less clean, it's gonna look more unclean. I don't want to keep my code as separate and as clean as possible. I don't lump too much stuff together. So this way is probably okay. As you can see, like the names are like crazy long. So these are the columns I want to rename. All right, so now that we have that out of the way, could I put on the, oh my gosh, that's so much better. So let me put this on the next code cell. So if you click on, if you press and hold shift and press tab, instead of moving forward, it will move backwards. So usually tab is to move forward, but shift tabs moves backward. All right. So this way I don't have to keep scrolling back and forth to see all the names. So these are the columns I want to rename. And then, all right, so what I want to do here is I want to do train equal to, let me see the syntax that I used. All right. So I'm gonna do train equal to train dot rename, and I'm gonna say columns is equal to columns to rename. I'm gonna say equal to this, and I want this to be small letter. And I'm just gonna repeat this twice, and here instead of doing train I'm gonna do test and var. All right, and here I'm gonna do return train test val. So basically, if everything goes as expected, when this code is run, all these columns should be renamed. All right. So let's cross our fingers and hopefully there's no bug in our code. And if there's error in our code, that's perfectly fine. We'll just fix it. I like error messages, you know, because you don't have to spend like. Actually, one of the reasons why I like error messages in data science projects is that depending on the type of projects and depending on what you're working on, for the most part, you don't have to spend hours and hours and hours trying to find the error, because it will tell you what the error is. The only problem that you could run into is like, let's say if you don't know how to fix the error that you find. All right, so let's see here. This should work as expected. So let's go and run it. Now let's do. I want to give this. Let me see. Let's call it train 2. I like to give things different names just to make sure I'm not overriding any pre-existing variable. So that's why I like to add something like 2, to create a new variable. So basically, right, I want the result of this code. And also, so this is the argument that I provided here is train encoded testing. The parameter is train encoded test encoded validation encoded, and that's why I put here in the doc string that the input is the encoded data frame or any data frame that needs to be renamed. And in this case, the parameter is train encoded test encoded validation encoded. I mean, I named the argument and the parameter the same thing. Don't get confused, so the name I give to the parameter is also happens to be the name of the argument. All right, I'm a little bit nervous about this, but let's run this. Okay, nothing bad happened so far. So now let's do train 2 dot head. The moment of truth. Oh my gosh, it works. All right, so everything works. Just to give you an idea of what we had before. What we had before was let's say train encoded dot head. All right, so you can see here this is what we had before we did the encoding. This is what we had before we did encoding, and this is what we have now. So instead of all of this, we have this. So I didn't change these column names. It's fine. So the names look a little bit better. The code just looks a little bit cleaner. And also in the future, as I keep writing this code, as I keep working with this data frame, I don't have to waste time writing long column names out. I can just use short column names like this. That's why I spent some time renaming the columns. I have written quite some code, so I'll go ahead and save this, and I'll go ahead and push it to GitHub. So get add, get commit message So let me see. Oops, Control Z. You know, I'm just messing up. I wanted to make this bigger, but I'll do that in a second. So get commit message, finished encoding, and renaming functions. Git push. And just because I'm semi paranoid, I'm gonna go here, refresh my page, and yes, the changes I made has been added. All right. So whenever I push stuff to GitHub, I don't just push to GitHub and hope for the best. Whenever I push to GitHub, I actually go to where the code is supposed to be, refresh it, and make sure it's there. Because I've had times in the past when I push to the wrong repo, like I push to a completely different repo. So I always double check to make sure I've pushed to the right repo. Um, and also for this, I wanted to see if I could increase the size of the distance. Is there like a thing that lets you increase? No. I'll keep um I'll keep coding, and sometime I'm going to look up how to increase the size, the font size for Windows Terminal. Yeah, I want to find out how to increase the font size for Windows Terminal. That's gonna be yeah. I need to find that out later, but not now. Let's keep coding. All right, so we've done that. So the next function we're going to create is a function. It's a function that rounds things. So as you can see, this has too many endings. If you scroll back here, you see this has long tails. So I'm just going to round those two values. I'm just going to create a function that rounds them. I mean, I could do it individually like this, but creating a function is always more fun, right? All right, so let's see. Function. And once again, why is this green? It's supposed to be blue. Oh, I think round is a keyword. Okay, so yeah, round is a keyword. That's why it was green instead of blue. I was like, wait, something is not right. All right. I need to get more water soon. Um, so here once again, I just want to be able to pass in my data frame, my trim, my test, and my validation data, and then I want to be able to round these functions. Round these columns, and of course I could also I could make a generic function for rounding where I provide the column names. If I wanted to make this more generic, I'll provide the training, the test, and the validation data. And also on top of that, I'm going to provide the column names here, like which columns I want to be rounded. So basically, if I just pass in the column name, it will get rounded. But I don't want to just create a generic round function that I could reuse in other data. I just want to create a function for this particular data frame and this particular project. So I'm gonna keep it stupid simple. Alright, just gonna keep it simple. So let's create a copy of our data frame. I like to give different things. I like to give different things different variable names just to make it clear which values each variable is referring to. All right. So now I have a copy of the data set. I want to make sure I add a doc string here. So a function that will round the values in some columns. Provide the data set and the columns below will be rounded. Alright, so I have my doc string that kind of give a little bit of preview about this, and then I have my I've gotten a copy of this, and basically I'm going to be copying this code right here. Let me see. Huh. So I want to round this. And of course, in the future, if like let's say I have other columns that I want to round, I'm going to put it here. And I want to repeat the same process for my test round. And whenever you are doing rounding, you can round multiple columns at the same time using, give me a second, I need to plug in my computer. All right, I'm back. Sorry about that. Alright, so whenever you are doing a round, you can round a single column or you can round multiple columns at the same time using a dictionary like this. Alright, so this is my test round, and of course I consider myself the queen of copy and paste. I'm gonna copy this and so basically this function is going to round these columns to 2 decimal places. Everything looks about right, and of course once we run this code we figure out if there's something wrong with it. But until then, let's go down and return train round. All right, so basically this function is very simple. It's just going to run the values. We are going to provide a data set, the data frames, and then it is going to round it for us. It's going to run these columns, and if in the future if you have more columns, we'll just add them here. But as for now, this is good enough. Let's go down and run this, and let's see if it works, right? So we want to yeah, let's use the same variables that we used above. But in this case, the variables, these are the parameters, and this is the argument here. Wait, something doesn't add up. Oh my gosh, what am I doing? That's in the wrong place. There we go. That's much better. I was like, wait, that doesn't add up. So let's go down and run this. And now let's do train2.head. And it works. So basically, before, the way we had it before, it had like so many decimals at the end. But with this simple function, it was able to put it to 2 decimal places, and then if you scroll the way to the end, this is also 2 decimal places. So wait, I feel like I'm missing something. Okay, everything is here. I was like, wait, for a second it seemed as if I was missing a column. All right, so we've done that. Let's see. I can go ahead and delete this. So we're almost done with this encoding All right, so these are the columns I said I wanted to drop, and I decided not to drop renew offer type, but I'm going to drop response. And I think I created a column for dropping stuff, a function for dropping stuff. So if we go here, yeah, so basically I created a function like last week when I worked on this project. I created a function for dropping stuff, so whenever I need to drop a column, I don't have to do it later on. I can go ahead and use this function. um, Unless, I mean, these are the columns I dropped before I did all my encoding, but now that I have encoded data, if I need to drop something, um, I can either reuse this function or I could just create a new function. It depends. It depends on how things are going. All right, so we are done with this. We are done with this. Let me see. What else did I want to run? Monthly premium auto is already rounded. If I go here, yeah, monthly premium auto is already rounded, so we don't need to round that. But still, let me go ahead and use my new favorite thing that I've just found out how to use. That is so cool. I find like little things like this so exciting. Hold up. Wait, it works like this. I think I need to put this at the end maybe. There we go. I just think that looks super cool. Hold up. Yeah. I like that a lot. I like today early in this live stream I learned how to use the tilde to create check marks. I mean like cross out stuff, and I think that's exciting. All right, so let's move on. What's next on our list? Well, on my list. Well, on our list because you're coding with me, right? So let's say we've done a function for random variables. We've done this function. We've done this function. We've done this function. The refactoring process is almost done. So now these are the functions we want to build next. So we want to build these functions and this function. And then next week, hopefully, well, next week or next 2 weeks, depending on depending on what we got, depending on what we get done today, and we'll start building a Plotly app. I'm excited for that. Basically, taking this right here and putting it in an application that you as a user can go to like a website and use. So that's exciting. I need to get more water soon. So let's begin with this right here. And let's work with that. I don't need any of this anymore, so okay. So this is what we are working on right now. We are working on building functions for the model. Actually, I think I was thinking of doing a function for the visualizations. I was, I was thinking of doing a function for the visualizations as well. It will just make it easier for me overall. Um, yeah, let me go ahead and add this real quick. And I think I might do this one next week because I'm I'm using Plotly for my visualizations, and Plotly doesn't work very well in Jupyter Lab. So next week I'm going to be using Jupyter Notebook or VS Code, and when I work with the visualizations, so that the visualizations will show up as I'm writing them. So function for visualization. I'm gonna add that here so I won't forget. Alright, so with that being said, let's go ahead and quickly get this done. Alright, so we want to create a function to split x data and y data for both y variables. Alright, so in this situation we have customer lifetime value and insurance premium as target y variables. Alright, so basically what I want to do here is I want to create a function to get x values and y values. That's the next function we are going to create. Oh, by the way, I have an extension that allows me to be able to do this. Maybe in a different video I'll go into details about extensions I use in Jupyter Lab. I think that would be a fun video to make. So let's call it DFXY. Why not? Why not? So the idea here is that we provide our training data, we provide our test data, and we provide our validation data, right? And then what we want to do is we want to define our x values and our y values. So let me add a quick doc string. Actually, I think what I just want to do this for a single data frame, and then if I want my x train, y train, and then I'll pass in my training data. If I want my x test, y test, I pass in my test data. I think that's how I want to do this. I need to get more water soon. Alright, so let's see. We are gonna say our y. Now we want to create no, I think this will work. So we want to say y is equal to train customer lifetime value. So actual insurance premium is the first y that we are working with here. So let's see. Where is it? Monthly premium auto. That's the name of the column. Alright. And then y2 is going to be customer lifetime value. So in this situation, right, we are working, I mean, it's basically using the exact same data set, but we have two different objectives, sort of two different models, two different projects. In the first model, we are predicting your insurance premium, and then in the second model, we are predicting what is the customer lifetime value. So y, we got y, and then training, and y2 train. And then, so we want our X. Yeah. So we want to drop our Y from our X. All right. So we're gonna see we are gonna say S string. We're just gonna be X. We're just gonna call it X is equal to train dot drop, and we want to drop columns. Right, that's the syntax for dropping stuff. Let me double check real quick. Drop columns equal to, then you put the columns in the list. Okay. Well, I can go ahead and put the columns in a list. Instead of using Y and Y2, I'm just going to put the columns in a list like this. I'm actually going to list the columns to drop. All right, I also put it here, why not? All right, so let me make sure I'm getting this right. So our Y value, or our Y column is monthly premium auto, and we also have a second Y column called customer lifetime value, and we want our X data to be everything but the two columns that is our Y, right? Because we don't want data leakage. So then we want to return Y, Y2, and X. Now let's go ahead and run this code and see if it works. Did I run this? Okay. And now, so let's see. Let's call it Y train, Y2 train, and then S train. It's going to be equal to XY. We're passing our training data, right? Or did I call it train 2? The last variable name that I use to store our data is train 2. Okay, just wanted to make sure. And of course, once I'm done with this code, I'll probably go back and change the variable names a little bit to make it more consistent or easier. But as for now, I'm just gonna use train 2, and let's run this. Now let's type in Y train and see if what we get. Okay, so it works as expected. We have our Y train, which is monthly premium auto, and then let's try out Y2 train. Customer lifetime value, and now let's try it X train dot head. All right, so we should be missing 2 columns right now. Okay, I think the columns. Okay, so I think those columns were dropped, and just as another sanity check, that's like I do this the shape. So we are supposed to have 50. Hold on. Let me do this. Train 2 dot shape. Okay, it makes sense. So in the original data we have 56 columns. After dropping the 2 we are supposed to drop, we have 54 columns. So that's expected. And I don't just, whenever I'm writing code, I don't just assume something is done right. I actually like kind of do checks and balances to make sure my code is working exactly as I expect it to do. So xtrain dot let me do dot columns dot d types dot columns. All right, and okay, that's too much. All right, and let's see. Yep, I don't see monthly premium auto, and I definitely don't see oh, I just noticed something. I most likely I don't see customer lifetime value. I just noticed something. So basically, these columns right here, I didn't change it when I did the name change. I did not change those ones when I did the name change. Give me a second here. Let me go ahead and add it to this real quick before I forget. And I want it to be renamed to renew. All right. And then I'm just gonna copy this line of code. I just noticed that, so I need to go ahead and take care of it while I still have it here. I'm not going to bother running all the code cells right now, but I have this here. So next time I run this code cell, these changes will take place. But as for now, I've kind of visually and manually verified that these columns, the appropriate columns, were dropped, because if you didn't actually drop your Y train from your S train data, then you're going to have data leakage and your model is garbage. You know what they say, garbage in, garbage out. All right, so now that we know our function works, we can kind of go ahead and use it to get our test too. So let's put it here. Training data, and I'm just gonna repeat this process for the test, and I'm not gonna do it for the validation data now. Let me see. Actually, well, I'll go ahead and get it done for the validation data. Why not? So here I'm putting in test 2, and here I'm putting in validation 2, and I'm changing this to test. All right, so that's my test data and that's my validation data. All right, so basically I now have a function for splitting my data into training and test data sets into y data, s y target variable, and x variables, as I'm trying to say. All right, so let's say that's the next thing. So drop y variable from x zero. Right. Oh, I remember this now. Okay, so x zero is only the top 5 to 10 features. Drop everything else. Okay, so I think after after running my model the first time, I decided that I wanted to keep only the top 5 to 10 features. I think I might do that later on. Right now, I don't. Let me say. Okay, actually, I think I might have the visualizations I'm looking for. Right. So for something like I think this is customer lifetime value. I just wanted to keep the top features. But I think I'm going to do that later. So right now I think I'm going to leave this as my generic x and y data, and then as I keep writing the code, I'm going to define my x to be everything. Let me see. Let me see. Because based on this model that I already created, I decided I wanted only the top features. So so this is customer lifetime values. And this is premium auto. Um, so the top features and okay, I think I know exactly what I want to do. The top features and customer lifetime value is a little bit different from the top features and insurance premium. So the features that has the most impact in customer lifetime value is a little bit different than the features that make an impact in customer and your insurance premium auto. So I'm gonna keep this separate. I'm just gonna focus on customer lifetime value. So let me go ahead and make sure I define that. So this I'm gonna keep it as separate project. Basically, I'm not going to try to lump it into the same thing. So what I'm gonna do here is I'm going to make sure I define this as model. So when I start working on customer lifetime value, I know I'm just working on customer lifetime value. Alright, so that's my training data, test data. Yeah, so I think what I'm gonna do, I'll go ahead and change this. Hmm. Mm, I'm trying to think about the best way to do this because I want to reuse this function, and the columns I'm going to pass in for x is going to be different for different models depending on what I'm trying to predict. So I'm trying to find like the optimal way to do this. Do I want to like be okay? Um, um do I want to do this here? Basically I'm gonna say my x train is equal to x train, and then x train because I'm only trying to pick out a few columns right here, right? I only want log through xuv. Let me do this here. So based on the model that I already created, right, to find out if only a few columns really matter when it comes to predicting insurance premium. So I'm trying to remember, how do you pick out just a few columns? I'm trying to think. Let me see. So the important columns here are, I'm gonna put it in a list. The luxury XUV column, I'm basically looking at this importance and future importances, right? So when I did a random forest regression model, these were the most important features, and basically everything else doesn't matter. So let me see. Actually, let me look at the future importance for. Never mind. Okay, so these are the future importance, and then luxury car is also an important feature. What did I do? I don't know what I did. So this, and then the type of coverage you have. Whether you have a sports car or not. Two-door. So these are like the important features. So instead of running this model with all these features, I just want to run the model with, like, let's say the top 5 to 10 features. Month since policy inception. So month since policy inception could be an indicator of how long they have been with the company. And the longer you stay with an insurance company, the more likely they are to give you a discount. So income does have a little bit of impact, just a little bit. So let's see, this is about the top 8 here. Income, and then month since last claim, and number of policies. I can probably do this like this and put several on one line so it doesn't like all go over. So So month since last claim, number of policies, and then let's just add education and number of complaints. So these are like kind of like the important columns. So how many is this? So that's 3, 6, 7, 9, 11, 12. So these are like the top 12 features that kind of help that sort of determine your insurance premium. And the reason why I wanted to limit it to 12 features is that when I build the Plotly app, which is going to be the user interface, that you as a user can go enter your information and get your insurance premium prediction. Of course, your insurance premium prediction is not going to be like 100% accurate. But the reason I wanted to create it like this is so that when you go and you enter your information, you won't have like too much information to enter. You only have to enter these values right here, and then if you enter these values, you'll be able to get an insurance premium prediction. So education is like your level of education, number of policies, and other stuff. So these are the important columns, right? Everything else is just extra. Okay, and then if we let's say go back to if we go to a different model, this one is a linear regression model which performed worse than the random forest model. So I'm kind of using the future importances from the random forest model instead of using the coefficients from the linear regression model, just because the random forest model performed better than the linear regression model. But as you can see, some of these columns kind of correspond to what the linear regression model deemed important. Not everything is corresponding, but right around the same information. Now, if you notice here, like in the linear regression model, right? Month since last inception and number of complaints open didn't make the cut as important features, but then again, this linear regression model is not like an accurate representation of the data. So I think I'm gonna go with the representation from the random forest model. And also let's look at other models. So if you look at I think I have a gradient boosting model. So if you look at the gradient boosting model, also the top 10, the top 6 features kind of match also between the gradient boosting model and the random forest model. But then again, in this situation, the random forest model outperformed the gradient boosting model. So I'm just gonna use the most important features from the random forest model to determine which features I just want to use for my X data. So I need to change my code a little bit so I can so this only will be the X data. Alright. And this is just for the insurance premium. Of course, we have to do something similar to customer lifetime value. So if if we go to customer lifetime value and look at the random forest model from it, so this is the linear regression model from it. If you look at the random forest model from customer lifetime value, the factor that has the biggest impact on your the customer lifetime value is here the number of policies and months since last claim, luxury XUV and other stuff. So these are kind of the ones that has the most impact, right? And let me say two doors. So they are kind of similar. Vehicle size. So if I go by the top 12 here, let me see. If it's like if this value and this value are the same, then I don't have to write two codes. So number of policies is here. Month since last claim, yep. Luxury XUV, month since last inception, yep. Luxury car is here. Income is here. Coverage is here. SUV, yep. 2-door sports car, 4-door education, vehicle size. So I don't have vehicle size here in this list. So basically I think, let me see, 1 2 3 4 5 6 7 8 9 10 11 12. Yeah, so basically the top 12 features that help to predict insurance premium also happens to be the top 12 features that help to predict the customer lifetime value to the insurance company. So I think I'm just going to use this list as my X values for both insurance premium, for both insurance premium prediction and customer lifetime value prediction. And now just thinking about it, right? Oh, something else just came to mind. So this is what I'm going to be using right here. So I think I'm just gonna call it important features. And I want to see if this works. I don't know, let's just call it tray here. I want to see if this works. If this works, then I'll just take this and put it in my function. But first, I want to make sure this works. So basically what I'm trying to do here is I'm trying to create a new data set that just has these columns. I kind of have forgotten how to create a new data set from an existing data set. How to pick the columns. But we'll see how this works. If it works, yay. Okay. Right. The name is wrong. All right. Number of complaints not in index. I could have sworn I saw number of open complaints. Boolean array. Let me see. Um, I'm trying to think creating a new column, a new data set from existing data set. I'm trying to see. Uh, I think I'm just going to do the old fashioned way. I'm just gonna do it let's say pd dot data frame. Mm, uh let me see. I'm trying to see let me google it real quick. Let me see pandas data frame from another. I've done this many times, but I just sometimes I just forget how to do stuff. So let me see. Okay, let's try this one. Let's see. Um. Okay. So this is kind of the syntax I was trying to use. Okay. So all data frame list of my data frame dot copy. Okay. I think I'm gonna use this syntax. There's so many different ways to do this. Okay. So basically, all data frame in this case x string, and then important columns, as I call them, dot copy. I think that's the syntax they use. So this, the list of columns, and then dot copy. I think that's a way to do it. Hmm. This doesn't make any sense. Let me see. That here for sure. I'm trying to see. Mm, So it is saying that this do I need to specify the axis? I think so. I think I may need to specify the axis. Dot filter axis equal to 1. No. Yeah, I've tried this syntax, but I don't know why it's not working though. Isn't that the first thing I tried? See, that's the thing with coding. Like, the syntax is always changing. Now I've done this so many times. It's like, what the heck is this? That doesn't answer the question. Let me try using dot filter, and then axis equal to 1. Let me try that. So basically xtrain dot filter, and then let me see. Oh, I think I know what the problem is. Hold up. Nope, hold up. Before I try this, what am I doing? Before I try this, I think right, because if you what? Okay. So I think since important columns is already in a list, right? I don't need to put the second bracket in it. So I think that might be the problem. Let's try this real quick. Oh, hold up. I need to remove this. It works. Oh my gosh, I figured out the problem. I had I had too many distance. Okay. So I figured out what the problem was. So basically, let's see, this syntax works, but it didn't work the first time because, as you can see, this is double list, double bracket, and the way I had it before, I had this, so basically I had like this right here, and then I also had this. So basically I had like 3 brackets. That's why it wasn't working. But since important columns is already in a list format, I only need a single bracket right here to accomplish the mission. But anyway, I had too many brackets. That's why my code wasn't working. I knew I wasn't crazy. Now let's do xtrain dot 3 dot head, and that's awesome. It only has the columns that we want. That's really good. So these are the columns that has the most impact on predicting insurance premium, and also predicting customer lifetime value. So basically what I'm envisioning right now is that on the website I'm going to create for this project, you just go in there, you enter a value for how many luxury XUVs you have, how many luxury cars you have, the type of coverage you have, and then once you enter all this information, you get a prediction on what your insurance premium should be, and your lifetime value to the insurance company. So that's fun. So, and also one thing I like to do is test my code outside the function. So since I tested my code outside the function, I'm confident that this code works now. I'm gonna actually take it, I'm gonna put it inside the function. So let's go back here. So Alright, so this works, and then um and here basically I'm gonna do my x is equal to the training data time columns dot copy, and let's go and run this and delete all of this. And all right, it works. So this is our new x data that just has the most important columns we're interested in, and we can go ahead and delete this and delete this and delete that. And all right, so this has been really exciting. So we created a function for splitting our data into y for our first target variable, our second target variable, and then our x values. And let's see. So what's the next on my list? So my list is to create a function for calculating my baseline model for create a function for the baseline model, and then I'm going to create a function for random forest regressor model. So actually, well, let me see. So basically, based on the initial modeling that I did right here, the random forest model kind of performed best out of, like, I only tried 3 different models, and I'm very satisfied with the results. So that's why I didn't like experiment with other models. But in the future I might come back to this project and maybe try out different models, but for now I'll just stick with a random forest model. I feel like the random forest model's performance kind of meets my MVP. The prediction is good enough. It's not excellent, it could be better, but it's good enough. And also after building the Partly Dash app, and the app is live online, after taking this project and putting it in an application, and once it's live online, I can always come back and change the model. And after changing the model, the the model that I've deployed will be able to make better predictions and have better results, you know, based on the updated model. So as of right now, I'll just start with the random forest. I'll just work with the random forest model. I might include a linear regression model in this refactoring, but as of right now, I'll just stick with the random forest model for sure. So so today we created a function for doing this, and actually I think I might end the live stream here. Next week when I come back, we'll start with the function for baseline model. So basically we are going to, like, if you look at this original notebook right here on the right hand side, we do have our baseline model, and basically I'll take this baseline model and take the random forest model and kind of put it in a function. I've got this is consolidating the code into a more concise manner and also more reproducible manner. And then after working with the baseline model, we'll do the random forest model. Maybe we'll also create a function for linear regression model. And then we are going to bring the function for sharply over. So I already have a function for sharply plot over here. We're gonna bring it over here. And also we might create a function for like different visualizations, like plotly visualizations. So yeah, that's quite exciting. So that's where we'll begin next week. Let me put a note here. And I'm gonna use my new favorite thing that I found. I just learned how to use this today, so I'm pretty excited. I keep using it. Basically, how to cross out things in Markdown. All right. So this is where we are gonna start next week. That's where we're gonna start building. We've done a lot of refactoring today. I'm very happy with the result that I got today. And if you have any questions, just let me know in the comment section. And of course, even if you watch this video after the live stream has ended, if you have any questions, let me know in the comment section. And also, I was thinking of starting like a Discord server where like we can ask data science questions, share videos, or like you can ask a question using a video, you can ask a question using pictures and stuff, and I'm able to respond to your questions using pictures and videos and audio. Because with YouTube, the only way to communicate is through text, right? You know, you can't send me a video on YouTube. So I was thinking of starting a data science Discord server for like where people can communicate and ask questions and things. But anyway, that's it for today's live stream. Thank you for being here. These are the functions we created today. Let me go ahead and run this. So these are the functions we created today. We made a big progress in our quest to refactor this code into something more usable, something more easier to read, comprehend, and work with. And I am seriously thinking of doing a different video where I teach you guys how to, like, different extensions I use in Jupyter Lab, so I'll be able to like have things like this, because this is not normal. Like normal Jupyter Lab, vanilla Jupyter Lab doesn't have this function right here. Anyway, that's it for this video. That's it for this live stream. Thank you for watching. And quickly, I'll just update this online, so get add. All right, let's go ahead and refresh this page. And let's see, yep, it's here as expected. It may not show up because it's a large file. Well, actually, this show up, so yep, everything is here as expected. All right, I just wanted to make sure that was online. That's it for this live stream. Thank you so much for watching. Let me know about your comments, and I'll talk to you next time, or let's say next week. Like next week, I want to live stream every single Saturday, starting at 10 a.m. and end around 12 or 1 p.m. So next week, please be back here. I'm going to be live streaming starting 10 a.m. Bye.